Hi there! Today we're looking at trigonometry, specifically elevation, and how the angle of elevation can change depending on how far away or how close to a building you are. This is Will Smith, and Will Smith is visiting the Leaning Tower of Pisa. The Leaning Tower of Pisa is 58 metres high. Will Smith is standing looking at the tower. When Will walks towards the tower, the angle of elevation from his foot to the top of the tower changes from 45 degrees to 60 degrees. How many metres did Will walk? When you're answering a question like this, it's always a good idea to draw a diagram. So here is my diagram. You can see that the vertical height of the tower is 58 metres. Initially, Will was standing at point C1, which is a distance of A plus B metres from the tower, but he decides to move closer, so he moves to a new position, C2, and C2 is a distance of A metres from the tower. So there are a few things that you should take note of. Firstly, the word vertical tells us that we are dealing with a right angle triangle. We've actually got two triangles here. So when you think of right angle triangles, trigonometry probably springs to mind. So if we look at the picture, we can see that we've got two triangles and that these two triangles have some equal properties. Most notably, H is 58 metres in both of these triangles. So the two heights of the triangles are the same. And using this information, we have to work out how far Will walked from point C1 to point C2. In any right angle triangle, we had the opposite, we had the hypotenuse, and we have the adjacent. So the hypotenuse is across from the right angle. The opposite is across from the lead angle, which in this case is 45 degrees. I'll just mark it in here so you can see it. This is the lead angle. And the adjacent is next to the lead angle. So once again, the hypotenuse is across from the right angle, the opposite is opposite the lead angle, and the adjacent is next to the lead angle. Now that we know how to label our triangle, we can put the names of the different sides to use. The properties of a right angle triangle means that there are a set of functions that we can use to determine the relationship between the lengths of the sides and the measure of angles. There are three sides to a right angle triangle, and we've already said that these three sides are the opposite, the hypotenuse, and the adjacent. The trigonometric functions that we are going to learn are sine, cosine, and tangent. These functions describe the relationship between the measure of an angle and the length of a side, which means that in a right angle triangle, the measure of a side is always related to the length of a side. So we need to determine where our angle is. So let's measure this from this angle x using the sine. So if we want to work out the sine of angle x, then we need to divide the opposite by the hypotenuse. If we want to work out the cosine of angle x, then we need to divide the adjacent by the hypotenuse. And if we want to work out the tan of angle x, then it's opposite over adjacent. So the vertical height from the ground to the top of the tower is 58 metres. The road between Will and the tower is level, and the height is vertical, so we know that this is a right angle triangle. Will is initially at point C1, a distance of A plus B metres from the tower, but he decides to move closer to get a better view, and Will moves to a new position, C2, and C2 is A metres from the tower. There are a few things that you should take note of. First, the word vertical tells us that we are dealing with right angle triangles, and trigonometry probably springs to mind. Secondly, if you look at the picture, we actually have two triangles that have a side in each that is equal to the other. So the height of this triangle is the same as the height of this triangle. Finally, we're asked how far in meters well walked, and this means what's the difference in meters between A and B. We need to use both triangles to find the answer, so we will begin with the largest triangle, which is AC1B. The larger triangle has a height of 58 meters and an angle of 45 degrees. It's right angled, so we know that we can use trigonometry. In this example, we won't be using the hypotenuse. We know that the angle is 45 degrees, and we know that the opposite is 58 meters. We know that the trig ratio that we'll have to use will have to link the opposite and the adjacent. So we're going to have to use the tan function. And tan is opposite over adjacent. I'll begin by filling in this formula. So the angle AC1B is 45 degrees. The vertical height of the tower from A to B is 58 meters. So let BC1 equal A plus B. Tan 45 equals opposite over adjacent. Opposite is AB and adjacent is A plus B. We know that tan 45 equals 1, and you can actually check this out by grabbing your calculator, pressing the tan button, keying in 45, press equals, and you'll see that that is equal to 1. So from that, we now know that 1 equals AB divided by A plus B. We know that AB is 58 meters, so 1 equals 58 divided by A plus B. And we know that a number divided by itself equals 1, so A plus B must be 58. Let's look at the next triangle. So we can see that the angle AC2B is 60 degrees. We know that AB hasn't changed, it's the same, the vertical height is still 58 meters. Let BC2 equal A. Tan 60 equals AB, which is the opposite, over A, which is the adjacent. If you stick tan 60 into your calculators, so press the tan button and key in 60 and press equals, you'll see that tan 60 equals the square root of 3. So the square root of 3 equals AB divided by A. We know that AB is 58 meters, so the square root of 3 equals 58 divided by A. And if you change that around, you'll see that 58 divided by the square root of 3 equals A. So A equals 33.49 meters. Now don't forget to answer the question. So we were asked to find how many meters well walked. That is the distance from towards the tower C1 to C2. A plus B equals 58 meters. A equals 33.49 meters. So B equals A plus B minus A. And B equals 24.51 meters. If we want to find the sine of x, then we need to use the trig function opposite over hypotenuse. If we want to find the cosine of x, then we use the trig function adjacent over hypotenuse. And if we want to find the tan of x, then we use the function opposite over adjacent. And this is true for all right angle triangles. Here are some questions for you to have a look at. I've put an example of the question on the next slide, and then I've put a link to the worksheet on the final slide. Here's an example of the worksheet, and there's a link to this on the next slide. What you have to do is you have to find the length of each of these triangles, so you need to find the adjacent. The height of both of these triangles is the same, so the height is 80 for both of them. You're given the first angle, which is 40 degrees. You're given the second angle, which is 70 degrees. And you need to use the tan trig function, and in this example, to work out the distance between point A and point B. Question 2 is the same, so the height is 60 meters. The initial angle is 25 degrees, then the person walks to point B and the angle is 65 degrees. So using the tan function again, work out the distance between A and B. There's a link on the next slide to the worksheet, so try to answer the questions. There's a challenge activity at the end as well for working out the angles. If you're working at the angles, don't forget to put your calculator into degrees and use the tan inverse key on your calculator to work out the size of the angle. So all of the answers must be written in degrees. Okay, thank you and good luck.